I invite you to a few dozen minutes of footage of the entire process of building a mobile sauna on a caravan chassis. By the way, on my channel you can find a video of building a stationary sauna in the garden. Since then, I have been thinking about building a similar sauna, but in a mobile version. It took me a few years to get around to it, but I am more than satisfied with the results. Enjoy and judge for yourself. I used a frame from a used post-demolition Swift trailer as a base. It was one of the larger trailers with a length of over 8 meters. So in order to use it in my sauna project, which is supposed to be up to 2.5 meters long at most, I had to give it some modifications. As you can see, in this caravan, on the steel frame, there is a platform which is made of 2 layers of 5mm plywood, reinforcing strips and foam insulation, which only in combination with the steel frame gives the whole the right stiffness. The steel frame alone, without the platform, does not form a solid unit that can support the trailer structure. The original frame had to be skillfully cut and welded so that it retained its strength and security and still fitted the legs of the trailer. The surprise and challenge was the drawbar of the trailer, which, as it turned out in the course of the shortening, changed its unfolding contour and barely fitted the hitch. After shortening and modifying the steel frame, I had to build a wooden platform on top of it, which served as the sauna's foundation. I used standard 38 by 63mm slats for the construction. A solid 5mm plywood was fitted to the bottom, painted with a special bitumen compound to protect the hull from moisture. I cut and used the rest of the old platform from the trailer from above between the slats as insulation. The final stage of work on the base was to fit the plastic mudguards to the platform, as in the original, fixed with staples and sealed all round with silicone. The joint between the new wooden platform and the frame was made with 10 8mm bolts and nuts. It is important to mention that the folding legs of the trailer had to be adjusted during the assembly of the wooden platform and the steel frame, because the system of fixing them partly in the steel frame and partly in the wooden frame, as it was done in the original. All modifications and adjustments were carefully thought out, assuming a balance between time and difficulty of tasks. In the following, you will notice that thick insulation foil has been laid between the wooden platform and the actual sauna floor. Micro-ventilation and ventilation holes have been drilled through the hole. Between the foil and the sauna floor there is a centimeter-thick air cushion for the circulation of air and the collection of condensation or as a drain in the event of splashes. Having built a suitable foundation, I could then set about creating the structural elements for the side walls of the sauna. I will call them whalebones here because they are shaped like this. They were glued together from 5 strips of 6mm plywood, 30mm wide, and shaped while being glued on a specially prepared table, which was made from the underside of an old trailer so nothing was wasted. I worked out the shape of the curve of this whalebone myself, based on the natural curve of the plywood. The idea was that the strips of plywood in the curve would put equal resistance, or pressure on the supports which were screwed to the table at its line of curvature. There are 10 wall-mounted supports alone, plus 4 more mounted on the inside at the corners, which are used there to attach the inner walls to them. These also improve the durability and rigidity of the entire trailer. The number of folds is not a coincidence, the aim being to have a gap of no more than 60 centimeters between each fold along the length of the entire wall. The outer sheathing is made of larch planks with a triangular cross-section, known in England as feather-edge planking. The dimensions of each plank are 2 thicknesses of 16 and 5 mm on each side and 170 mm wide. The boards were dried, sanded, sprayed with fungicide and finally painted with wood varnish. The preparation of the materials alone took about 90% of the total construction time. Once all the necessary components were prepared, the trailer with the chassis was set up and leveled, and within a day the wall structure and sheathing were built on it. You can see the whole process at a considerably accelerated speed right now on screen. The whalebones were twisted where the platform has its cross reinforcements. At the time when the sheathing was built, I did not yet know that my design would be subtly altered and modified with an external short canopy located at the rear. You will be able to see this modification later in the video. Its purpose is to create a short 20 cm porch over the sauna door. Once to protect this section from possible rain, two for aesthetic reasons. Once all the whalebones forming the outer structure had been tightened and fused to the top beam, the framework had to be carefully leveled and stiffened so that the heights at both ends matched and it was not overbite to either side. Vertical and transverse beams installed in the front and rear walls helped to stiffen the structure. You can follow the whole building process in real time, often at a very fast pace, but I try to include all the necessary construction steps in the recording. Before laying the first roof covering board, the edge of the chassis rail was protected with thick film. The purpose of this is to prevent any leaks in the sheathing and to drain any water that condenses on the moisture-proof foil. The planking was fitted overlapping from bottom to top. As you can see, the first two rows had to be cut and fitted to the wing arches of the trailer. The whole job turned out to be extremely creative and enjoyable. In order to get the overlaps on the individual boards evenly sized without having to measure them all the time, I came up with a simple wired tool which made the job much quicker. You will be able to discover it somewhere on the recording. At this point I have to admit to a small construction error, because between the whalebone and the sheathing, a vapor-proof membrane should have been laid down first. However, if I had done this, I would not have been able to discover the micro cracks in the planks which I only noticed from the inside. These would not have made much difference, however, as any water that passed through would have been carried away along the foil to the outside. However, as you will be able to see in the video in a moment, all the cracks and crevices have been reinforced and sealed with glue. The roof sheathing boards were attached to the whalebone with waterproof glue and, of course, screws for better rigidity and durability. The very top was built up with two planks of sheathing. These were tapered and joined with glue and screws in a step milled at the joint. The front wall of the sauna, from the hook look, has been structurally stiffened and provided with two windows. The windows are 20 by 40 cm in size and were ordered from the glass company and are made to a high standard, just like domestic windows. It is double glazed, separated by an insulating strip. The thickness of the entire double glazed unit is approximately 21 mm. The panes have been fitted into the openings of the windows with special elastic foam and silicone with a few millimeters of play on each side, so that when the structure is in operation, the wooden elements do not touch the panes and no force can act on them, which could cause them to break. On the outside, they were protected with a decorative trim and sealed with silicone. The outer planking of the front wall was made from 12 cm wide tongue and groove boards, 12 mm thick. As usual, to give the structure rigidity and durability, each board was laid with waterproof glue and fixed with screws. The edge of the joint between the roof sheathing and the headboard was sealed with filler glue. The entire front wall was painted with the same wood varnish as the roof sheathing boards. Obviously 2 coats were applied. You can see the differences in shade after the first and second coats were applied on the video. As I already mentioned, pieces of the old underside of the trailer were placed in the chassis frame as insulation. This is insulation foam finished on both sides with a 5 mm board. These pieces, fitted together earlier like a jigsaw puzzle, were glued into the voids between the structural beams of the chassis and sealed with insulation foam. Any leaks and voids in the chassis and later in the walls were also filled with insulation foam. As you can see from the inside, many of the sheathing boards have micro cracks on the knots and leaks between the boards. This was particularly noticeable on the inside, where the twilight allowed light gaps to be seen. I did my best to secure and seal them with filler glue, which probably further added to the durability of the structure. Later in the video you will be able to see that at the back of the trailer I decided to create a short 40 cm platform to form the vestibule of the sauna entrance. This is covered by a 25 cm roof overhang, which was created when the rear wall was pulled back into the sauna. Under this platform, a thick foil is laid, and on top of this, milled boards sealed with silicone and screwed to the structure. To make the decorative fender arches, I made a special template which I used to trace and cut out the necessary pieces. The edges of the plastic wheel arch and roof sheeting were sealed with silicone and bonded with screws. I wanted the arches of the wheel arches to be made of wood because they would naturally fit in with the fashions of the whole trailer. Special wooden spaces had to be fitted between the edges of the arches to compensate for the uneven side surface of the roof. The pieces were, of course, painted the same color as the roof sheathing, and fixed and sealed with filler glue and screws. The finishing of the leading edges of the front and rear roof were also made from wooden arches. A 2.5 cm thick, 20 cm wide plank was fixed to the edge of the roof, after which the edge arch was traced onto it. For obvious reasons, the whole structure consists of several elements. On the inside, the roof sheathing was covered with an insulation foil to prevent any leaks. This is laid overlapping from the bottom to the top, so that any leakage can run off to the outside. As I have already mentioned, it would have been better to lay the foil before the outer covering of the roof. But now I have to assume that the foil laid in this way will still do the job. As already mentioned, ventilation and micro-ventilation holes have been drilled in the sauna floor, their additional purpose being to drain any excess water that might be splashed in the sauna. Thick foil was laid between the sauna bottom and the floor itself, after which I inserted plastic tubes sealed with silicone through the holes drilled in the bottom. The floor itself was made of boards milled on one side, which were treated with wood oil before being laid. As you can see, these boards only cover the part of the floor that will be used for walking. Under the benches, the feather boards will be laid in an overlapping pattern, simply because I have some left. The sauna has been insulated with polystyrene placed between the outer sheathing and the inner proper wall. In hard-to-reach places I also used construction foam. I laid the polystyrene foam from the bottom to the top, building it up successively with the inner planking. The first 60 cm of the wall behind the benches was made of the remaining feather boards, thus using this material to the full. The rest of the visible wall was made of tongue and groove paneling boards measuring 94 mm wide and 8 mm thick. Although the polystyrene purchase matches the thickness of the structure's supports, in practice it turned out to be a few millimeters too thick and exerted too much pressure on the walls. I compensated for this by heating it externally with a heat gun, which caused it to shrink and lose a few millimeters in thickness. The paneling boards were laid with waterproof wood glue to both the structural supports and the tongue and groove. They were fixed on the outer edges with screws and in the middle with nails using a gun. As you can see, there are dead spots on the structure supports connecting the head walls to the whalebones, where there is no how to screw the covering. I had to add pieces there to which the paneling boards will be fixed. It took me several hours to lay down the polystyrene insulation and to build up the inner side walls with paneling boards. The inner walls may seem quite fragile to you because of the thickness of the board used, only 8 mm. However, the polystyrene insulation fits quite tightly and the planks on the wall stick to it, preventing the pirogues from becoming unstuck or damaged when accidentally rubbing against the walls. In addition, the thickness of the wall boards is just right to reduce the weight of the trailer. In the next step, I screwed a timber frame to the side walls from the inside to assemble the inner plating for the front and rear walls. This was mostly made of muslin stitches for the construction. In parallel, I made the face of the curved profile trim for the edges of the front and rear construction walls. Since the mudguards of this trailer are just thin plastic, I decided to make an arched finish for them out of wood, which was filled with insulation. In this way, the whole sheathing will already be properly insulated and heat loss will be avoided. The outer rear wall is made of 12 mm thick tongue and groove boards, the same as the front wall. The doors have been designed specifically for this caravan. Their skeleton is made of structural beams cut in half and milled to the groove of the sheathing boards. The same planks as those used for the walls of the caravan were used for the outer and inner plating of the doors. The frame was fitted to the door frame before the boards were covered. The door has a window and a vent that fits elegantly into the lower part of the door. The vent has an adjustable opening and a double insect net. On the outside, it also has a drip cap to protect against rain. All made of wood. Styrofoam is inserted between the planks of the door leaf to improve insulation. The doors have no handles, only pull handles, and a stop lock has been fitted to hold them closed, while a lock for closing the trailer is fitted in the side wall, where the bolt goes through the frame when closed and thus locks the doors. The door is fitted in the frame on 3 hinges. At their bottom, a lintel has been made of wood as well. Of course, they are only painted on the outside with the same varnish as the rest of the sheathing. The exterior sheathing on both the roof curves and the front and rear walls has been double painted with a very good quality varnish. I think this will prolong the life and help prevent any degradation of the wood, exposed to the weather. I'll skip right to the roof where I installed the chimney for the exhaust, which of course is made of stainless steel. As a collar between the roof sheathing and the chimney, a rubber gasket, special for this, has been fitted to prevent leakage. And now a little about the construction of the storage compartment. This is an additional piece of construction, bolted to the front wall, to store the gas bottle, battery and water tank. It was made in the same style as the whole trailer. Constructed from elegant whalebone arches, painted with damp-proof paint and clad with clown boards like those in the interior sheathing. Opening wide storage flap fitted with 2 locks. All designed in detail to drain rainwater to the outside, with grooves milled into the structure, and the use of seals to prevent leakage while driving. The curved trim pieces were heated with hot steam to bend to the shape of the structure. The entire shell was, of course, double painted on the inside and outside in the color of the trailer. Original locks with flaps as protection against water or dust. And now I'm on to the final stage of the exterior, the second painting of the roof, the installation of the curved trim on the edges of the trailer at the front and rear, and the installation of the storage compartment. I have to say that the whole thing looks quite nice and makes a positive impression. Now it's time to move back inside. Before the final build, I'm going to install the trailer lighting inside and outside, and complete the insulation in the front and rear walls with styrofoam. Due to the thickness of these walls, which are about 5 cm thick on the inside, I'm putting in a double layer of 2.5 cm thick boards. Insulated in this way, the trailer should keep the heat inside perfectly. It takes several hours of work to lay the inner plating on the front and rear walls. Most of it is taken up by the fitting and trimming process, which is not visible here. The actual nailing of the boards is a pleasure. I nail the boards with an automatic paneling nail gun. Some of them have to be carefully hammered in addition. I use a thin socket spanner as a tapping tool. As far as the exterior and interior construction is concerned, I am slowly approaching the end. I still have to do some minor, but also labor-intensive finishing of the curved edges of the walls on the inside, the window work on the inside, the installation of the cables and, of course, the design and construction of the sauna benches. Later in this video I will show how I converted the gas fire for use in the sauna, as well as the construction of the electrical installation for the driving lights and the lighting inside. As sauna heater are in my opinion overpriced, I decided to convert an ordinary domestic gas fireplace into a sauna fireplace. Its nominal power is 4.5 kilowatts. It has a manual switch and flame adjustment. For my part, I upgraded the nozzle, as the original was for natural gas, and added a frame to hold the stones on its sides and top. On the screen you can see the process from the construction of this frame. I used 2.4 mm thick sheet metal and 2.5 cm steel profiles. The idea for the shape I gave it was taken from the internet, and you can find ideas and ready-made sauna heaters there. The structure was solidly welded to the fireplace housing and finally painted with heat-resistant paint for motorbike cylinders. I think the effect can be considered satisfactory. And now it is high time to get down to the business of fitting lights. I have decided to purchase and fit LED lights here. In a compact design, they have low beam headlights, stop lights, active turn signals and a reversing light. Although the manufacturer assured me that they were waterproof, after examining them I found that they lacked much in the way of this, and I additionally sealed them with silicone. To mount them in the trailer, I made specially shaped stainless steel housing shades to fit them. These shades were screwed to the trailer structure and then the lights were fitted into them. The wiring diagram was found on the internet, but here I must add that I modified the connection slightly, as the lights do not have a fog light and the reversing light cable was plugged in instead. The cables were laid on the outside and nailed to the trailer chassis with brackets. There is a waterproof revision at each lamp for the electrical connections. The rear wooden housing is milled to hide the cable between the lamps. The trailer also has LED position lights at the front, plugged into the same circuit as the tail lights, and a set of reflective lights necessary for legal travel on the road. As with any build, there's a lot of essential work that you can't see but takes up a ton of time. You can see the finishing of the locks, the frame moldings, the window trim on the inside, and, believe it or not, there are a few more jobs that I will return to. Every caravan should have steps that are safe to climb on. At first I thought of a non-integrated extension, but this did not match my skills and the standard of the work I had done so far. Eventually, a design was born in my head, which has now been realized. You can follow the progress on the screen. The steps are, of course, made of matching timber. I used a single-sided milled deckboard for the construction. The stair structure is 1 meter wide and about 50 centimeters high and has 2 steps. At its rear end, I have fitted specially turned rollers that will fit into the chassis-mounted guides. To improve strength, I have used additional sheet metal reinforcements at the fixing points. The steps are intended to be an integral part of the trailer and are therefore designed so that they can be folded up and hooked under the trailer chassis without being removed before driving. The lower part of the steps ends in an arch and is covered with sheet metal, the arch being designed to adapt to a surface that might be sloped depending on where the trailer is parked. At the front end, the steps have mountings to hang them with bolts fitted to the chassis. The bolts have springs and pins to hold them in position and prevent accidental opening. An additional board has been fitted to the lower step at the required angle to mount the number plate and reflective lights. The steps have been painted a tone darker than the entire trailer. Note that the process of unfolding them and retracting them again takes seconds and is extremely easy. And now back to the work of installing the utility lights on the trailer. On the outside, I have placed a motion sensor activated spotlight above the porch. On the inside is the same spotlight for lighting the trailer inside, switched by an illuminated switch. On the outside, there is a switch for the side LED lights in the canopy above the door. When the external lights are switched on, the effect makes a pleasant sensation. The next stage was further finishing in the form of the joining edges of the inner walls. These were made from a 1.5 cm quarter roll. In order to be able to fit them into the curves of the trailer walls, I had to heat them with hot steam in order to soften them and make them sufficiently flexible. And I still didn't avoid cracks. In order to heat them evenly, I inserted them into an aluminium tube into which I fed hot steam from the steamer. I must admit, the installation was successful but labor-intensive. At last it was time to gather the material for the sauna benches and get to work on the benches themselves. The structure of the benches is made entirely of 38/63 of a millimeter structural timber beams. The seats are made of 205/94 of a millimeter planks. Part of the idea was taken from the internet. Adaptation and execution are entirely my own. The structural frame of the benches did not need to be sanded, but the seat boards did. This was a labor-intensive and tedious job. After fitting the construction into the interior of the sauna, I started screwing on the seat boards. This was quite interesting as I had thought of screwing the boards into the frame from underneath so that the screws were not visible. Holes had to be drilled in the frame at an angle through which the planks were fixed with special screws. The end result was satisfactory. I also wanted the front of the benches to be enclosed with a wood panel. This way you can always hide something under them and it won't be immediately visible. I built 2 panels out of wood planks. There are 3 planks in each panel, which is more than enough for this purpose. The panels are mounted on specially designed pegs. This is a very simple and easy construction and it takes a second to take them down and put them up. I also decided to make an uplift in the shape of 2 chairs mounted on top of the main benches, for those who like the temperature extremely high inside, and backrests or headrests in one. The fully enclosed interior creates a pleasant atmosphere, especially in the evening when the bench lighting is switched on. As you can see, the backrests and headrests are placed loosely and can be hidden under the benches when not needed in full. Once the benches were installed, it was time to hook up the fireplace heater along with building up the flue pipes and sealing them. And right after that, I took care of making and installing the vents on the front wall. All made of wood, of course. On the front side it is an openwork grille, made of oak for better durability. On the inside, It is a frame with a sliding flap to close off the air supply. There is a PVC pipe inserted into the wall, the ends of which are fitted with a fine insect net. Finally, I tackled the finishing touches to the storage compartment, where ventilation holes had to be drilled in case gas could accumulate in it. The locker holds a normal-sized gas cylinder, a battery, and there is room for a water tank. And, with the outside work done, a quick fitting of the plate and reflectors and mesh for the underbody vents. Back inside, I am fitting light switches in the seat planks and LED light strips under the benches to give the lighting the right atmosphere. And while we're at it, I've added the shade I designed for the overhead lamp, all made from wood, of course. And that's it. We've reached the end of the work and almost the end of the video. Have a look at the final results and let me know what you think of the project. I will soon put up a video about the costs of this project. I invite you to watch it in advance. That's all for now, and thank you for lasting until the end.